Welcome back guys sa ating calculus-based physics. Magpapakadalubhasa ulit tayo sa ating bagong topic, derivative as the slope of a curve. Yan, para to sa finals, part 1. So, reviewin natin yung diniscuss natin last midterm. So, compared sa derivative, mas madaling i-derive yung formula ng integral, no? Mas complicated yung derivative, no? Yan, na-discover natin yan nung last discussion natin. No? So, yung na-derive natin na formula for derivative, df of x over dx, yan, limiting process ang tawag dito, no? Na formula. So, ito yung ating limit. Ito yung ating formula for the derivative f of x plus change in x minus f of x over the change of x. So, review natin yung triangle yung change or d for delta. Basahin natin up to now. We have emphasized the idea that the derivative of a function of x is given by the limiting process. Ito na yun. We saw that this form was convenient when we had an explicit way of calculating f times x plus the change in x. So as we did by using series expansion. So gumamit pa tayo ng mahabang derivation, no? Yung series expansion. Sa integration, sa integral, hindi natin kailangan gumamit ng series expansion. No? However, a lot of words are required to explain the steps involved in doing the limiting process. Okay? Indicated in equation 55. Ito yun, nasa taas. In contrast, the idea of an integral as being the area under a curve is much easier to state and visualize. So, mas madali i-explain or mas madaling i-derive, no, ang formula ng integral. Now, we will provide an easy way to state and interpret the derivative of a curve. So, para daw maging madali din yung derivative, ito yung ating gagawin. No? Consider the function of x or function f of x graph in figure 20, nasa baba, at a distance x down the x-axis. Yan. Ito yung x-axis. Ito yung distance. At meron siyang height slightly farther down the x-axis at x plus change in x. The curve has risen to a height. Yan, meron siyang height. Ano yung height natin? F of x plus change in x. Ito yon. Yung initial height niya, siya si f of x. May initial height. So, nag-speed up siya. Bumilis na bumilis hanggang dito. This is the initial distance. Okay? And the corresponding function, f of x, ito yon. Ngayon, as it goes farther, yan, up to here, ito yung fx plus the change in x. Ito naman yung kanyang distance. Okay? So, tandaan natin si f of x ay equal kay y, no? Yan. Diba, coordinate plane? Kung ito si x, si f of x ay si y. Review ulit natin definition ng derivative compared sa integral. Pag sinabing derivative, yung change ng dalawang point. Sinasabi nating slope. Okay? So, ito slope, slope. So, nagkaroon ng change sa slope from slope 1 to slope 2. So, that is what we call derivative. Pag sinabi naman integral, ito yung sinasabi nating curve. Ang hinahanap natin yung area. Integral is always equal to the area under the curve. Yan. Ito yung area under the curve. Yung derivative, yung change nung scope. Ito yung nasa taas niya. Okay? So, yun ang difference nila. So, right now, tapos na tayo sa integral. So, hindi na natin papansinin yung area under the curve, no? Ang pag-uusapan natin ngayon is yung tuktok, yung point or yung slope ng curve as it changes. So, again, ito yung initial distance niya. Ngayon, nag-speed up siya. Nagkaroon ng change. Nakarating siya rito. So, we have the x plus change in x to represent the new distance traveled. So, itong area na to is the change from here to here. Change or the delta x represents the change. Pagdating naman dito sa taas, sa function niya, kay y, yan. Ito yung kanyang nire-represent. F of x plus change in x. In figure 20a, or figure 20a is a blow up of the curve in the region between x and x plus change in x. So, ano yun daw? Blow up, ibig sabihin, pinalaki para makitang mabuti, no? So, nasa yung 20a. Ito 20a. So, yung portion na to daw, pinalaki natin, no? Blow up. Ayan, ito yung portion na to. Pinalaki natin at ginawa natin ng triangle, no? Para makita natin yung portion. So, makita nyo, may konting space sa gitna. Okay? Kasi, itong line na to, curve siya. Okay? And then, again, itong part na to, okay, is represented as f times x plus change in x minus f of x. So, you will notice, yung part na yon ay ito. Okay? Sa formula. So, kinukuha natin to using this formula. And then, in relation, dito sa ating graph, ito yon, ito yung peak or yung slope. Final slope, ito yung initial slope niya, f of x, yung A, C, and B. So, if we draw or if we connect the 3 points, we can have a triangle, If we have a triangle, then we can measure the distance of the 3 lines. So, we have the angle here. So, ito naman yung change in x, ito yon, So, itong part na to, ano yung pinalaki natin? Again, ulitin natin. Ito yung part na to, Yan, ito yung pinalaki natin. Ito yung curve. Yan. So, ito yung ibig sabihin na, Figure 20a is a blow up of the curve in the region between x and x plus change in x. If the distance change in x or delta x is sufficiently small, the curve between x and x plus change in x should be appropriately or approximately a straight line. And that part of the curve should be approximately the hypotenuse of the right triangle ABC seen in figure 20A, So kung ito daw ay kung hatiin pa raw natin to sa mas maliliit na na slope, etong curve na to na medyo merong space pa, kasi curve siya, hindi siya pantay, hindi siya straight line, ay magiging straight line daw yon. At yung bawat triangle na gawin natin ay magiging exact, hindi siya curve, magiging straight line yung kanyang hypotenuse. Since the side opposite to the angle is, ito theta yan, angle theta is f times x plus change in x minus f of x. And the adjacent side is change in x. We have the result that the tangent of the angle theta is, so hanapin muna natin kung anong sinasabi dito. The opposite to the angle. Ang opposite to the angle, ito. Yan. Yan, opposite to the angle. So ito yon, ito yung angle natin, opposite, katapat. So itong side na to. Adjacent, itong nasa ilalim, change in x. So kung kukunin daw natin si tangent, bakit si tangent ang kukunin natin? Kasi si tangent is equal to opposite over adjacent. Sa trigonometry, yan ang formula to get the tangent. So opposite over adjacent. Ano si opposite? Ito. At si adjacent, ang ating divisor, change in x. The tangent of the angle at which the curve passes to the point x is called the slope of the curve at the point x. Okay? So, ito daw yung tangent. Okay? The tangent of the angle at which the curve passes to the point x, nasan si point x? Ito, is called the slope of the curve at the point x. Thus, from 157, we see that the slope of the curve is equal to the derivative of the curve at that point. We now have the interpretation that the derivative of a curve at some point is equal to the slope of the curve at that point. While the integral of a curve is equal to the area under the curve up to the point. Yan. So, this point and this point, na-determine natin yung kanyang tangent. So, ito yon. Okay, the tangent of the angle theta. The tangent of the angle theta at which the curve passes through the point x is called the slope of the curve at that point. Para mag-gets nyo, no? Pag sinabi mo kasing slope at pag sinabi mong tangent, yun yung line adjacent to the slope, no? So, pag sinabing tangent, kaya makikita nyo dito, yun yung line na yun yung tangent, no? Ito yung ating point x, no? Ito yun, ito, point x. Yan, ito, point x. Pag nag-draw ka ng tangent line, ibig sabihin, from here, dadaan ka rin sa point, direction. Kaya makikita nyo, yan, pareho, di ba? So, yung slope daw at which point x is located is equal to the derivative of that slope. We now have the interpretation that derivative of a curve, yan, hindi pala slope. Derivative of a curve at some point is equal to the slope of the curve at that point. Okay? So, yun ibig sabihin tangent line, no? Okay? So, we go now to negative slope. In figure 22, we compare the slopes of a rising and the falling curve. Ito yun, nasa baba. Positive slope, rising. Negative slope, falling. We compare the slope of rising and falling curve. In 22a, where the curve is rising, the quantity f times x plus change in x is greater than f of x, kaya siya positive, no? And the derivative or slope is positive number. In contrast, for the downward curve in figure 22b, in which f times x plus change in x is less than f of x, the slope is negative. For a curve headed downward, we have a negative tangent. Right? So, yung tangent niya, pababa kasi. So, we have a negative number. No? Ito yung f of x, positive siya kasi pataas. Nakita nyo, mas mataas siya kaysa kay f of x. Sa negative slope, mas mataas si f of x kaysa kay f times x plus change in x. So, yun lang tatandaan nyo. So, we will have an example here. Estimate the numerical value of the slope of the curve shown in figure 23. Ito yon. At points A, B, C, D, and E, 5 na points. No? In each case, do a sketch of f times x plus change in x minus f of x. So, gawin natin to, for example, no? So, ito yung line. Lagyan natin tong blue. Yung ating pan-drawing. Yan. So, susundan lang natin yung ating example. So, we draw a line here. O, katulad dito. Right? Gawin natin straight. Yan. So, katulad dito, yun, no? Gawalan tayo ng triangle. So, yung point, Okay, connect natin dito. Yan. So, palakihin natin. Pag pinag-connect natin to, yan, we can have a triangle, no? So, ang di-determine lang naman natin yung estimate. Ayan. Gagawin natin, estimate the slope at the various points indicated. No need to compute, no? Estimate lang natin. Your answer should be roughly positive 1, 0, negative 1, no? Or positive infinite or negative infinite. In this case, kasi mas mataas si B kaysa kay A, si F times X minus change in X mas mataas kay A. So we have a 1, no? Dito naman, so we again gagamitin natin tong line na to, but naka-reverse naman siya, no? Ito reverse. Yan. Connect again. So at this point, at this the second example, pababa tayo, no? Mas mataas sino? Yung initial si f of x kesa kay fx f times x plus change in x, no? So we have a negative 1. How about this example? Yan. Okay? So, kung gagamitin natin to, pababa, and then we will connect this one here. Okay? Then connect here. So, makikita nyo, narito yung ating line. Okay? Ito yung line natin. Ano sagot natin? Makikita nyo dito na halos magkapantay na sila. So, if we can estimate this, we will have a 0 para sa derivative nitong dalawa na to. At ito, obviously, up, we have a positive infinite initial final value. So, since siya straight, and then curve, then straight, we have a positive infinite. Next, we go now with exponential decay, a curve that we will encounter several times during the course is the function e negative or to the negative ax power. No? So ito ang tinatawag nating exponential decay. So remember, na-discuss na natin to si e, which is, balikan natin, ito, ayan. Ito natin yung ginamit. Integral of the exponential function. Yan. Si e-ax ay isang exponential function. No? Ngayon, pag yung kanyang power naging negative, it will become an exponential. It represents exponential decay. Since exponents always have to be dimensionless numbers, we are writing the constant a in the form of 1 over x0, so that the exponent x over x0 is more obviously dimensionless. The function e to the negative x over x0 has several very special properties. At x0, it has the numerical value of 1, no? Because if x is 0, then x over x is 0. So, nasa na yung negative? Wala naman tayong negative na 0, no? So, 0 lang siya at lahat ng number raised to the 0 power is always equal to 1. So, this numerical value, this exponential function will have the value of 1. When we get up to x equals x0, the curve has dropped to a value. Ayan. Babalik na natin yung negative kasi meron na tayong negative 1. No? Kasi kung 1 daw si x, so 1 over 1 will give us 1. So 1, e will become will have the power of negative 1. No? And negative 1 is any number raised to negative 1 will give you 1 over the number, no? In this example, we have 1 over e. So 1 over e, using our calculator, will give us an estimated, yan, nakita nyo, hindi na siya equal, no? Estimated value at 1 over 2.7. When we go out to x, naging 2 na si x. The curve has dropped to the negative 2. Okay? So we have 1 over e squared. Sa tatlo, if x is equal to 3, then we have an exponential value of 1 over e to the third power. No? This decrease continues indefinitely. It is the characteristic feature of an exponential decay. At ang isang example, no, ng isang real life matter or object na nagdi-decay ay ang particle. Okay? Katulad ng electrons, protons, no. So meron tayong isang particle na tinatawag, no, yung tinatawag na muon, no. So mabilis mag-decay ang muon pero may iba pang particle, no, na mas mabilis sa kanya mag-decay. But in this example, si muon, no, ang pinakamalapit na magandang example with regards sa exponential decay. In the muon lifetime experiment, we saw that the number of muons surviving decreased with time. So meron tayong machine, meron silang machine na pan-detect ng particle. Ito yon, nakaka-detect ito ng muon. So yung mga white lines, no, yun yung number of muons na nakikreate at na-detect, no, ng machine. Pero mabilis siyang mag-decay, meaning mabilis mawala. Yan, no, nagtataas baba yan, no, yung white na lines, no, dito sa ating graph. So pag may tumaas, ibig sabihin may na-detect siyang number of muons at unti-unti siyang bababa. Katulad nito, may mga bumaba na. Yan, ibig sabihin na nagdi-decay na, namamatay na isa-isa, no, yung bawat muon na yan. So how to compute the decay of this particle? No? So we use the exponential decay principle or formula. In the case of muon, at the end of 2 microseconds daw, more than half of the original 648 muons were still present. So, 2 microseconds, kalahati nun, no, na lang natitira. So, ang original na na-create na muons or na-detect is 648. After 2 microseconds daw, naging half na lang. By 6 microseconds, only 27 remain. So the decay of these muons is an example of an exponential decay of the form. Number of surviving muons equals number of muons at the time, no, yung natitira, times the exponential decay factor, where T0 is the time it takes for the number of muons remaining to drop by the factor of 1.2, 1 over 2.7. Well, remember, ito yung factor na to, no? That time is called the muon lifetime. So, kung gaano daw siya katagal bago maubos or makarating sa 1 over 2.7 factor, yun yung tinatawag na lifetime, no? We can use equation 161, ito yon, to estimate the muon lifetime. In the movie, sabihin ng movie, ito kasi yan, galing kasi ito sa video, no? In the movie, the number of mesons or muons at the top of the graph reproduced is 648. That is at time t equals 0. Down at time t equals 6 microseconds, the number surviving is 27. So putting these numbers into equation gives us the following, no? 27 surviving muons equals 648 initial muons times the exponential decay factor, which is e to the negative 6 over t0. Saan galing si 6? Yung microseconds. So, negative ang ating formula. So, we just copy the sign, no? So, e to the negative 6 over t power equals 27 over 648, and it will give us 0.042 micro or lifetime ang tawag, no? 0.042 lifetime. Take the natural logarithm ln of both sides of the equation. Remembering ln, ex equals x gives us ln times e. Okay? So ito yon, ln times e, which is 0.042. Yun yung factor natin, will give us negative 3.17. So remember si ln, natural logarithm, meron tayong sa calculator. So when we enter 0.042 on scientific calculator and press the ln key, it will give us, no, the answer as negative 3.17. And if we divide this by, if we make this as the divisor for the microseconds, then we will have 1.9 microseconds. No? So this is close to the accepted value of 2.2 microseconds, which has been determined from the study of many thousands of muon decays. No? So ito kasi yung standard lifetime ng ng mga muons, no, bago sila mamatay or mag-decay, no, totally mag-decay. Ito yung tinatagal nila. So yung computation natin halos malapit na sa kanilang lifetime, no, using the exponential decay factor. Ano naman yung half-life? The exponential decay curve, lifetime decays, yan, lifetime kasi to, yung T0, lifetime yon, no? 2 1 over E equals 1 over 2.7 of its value at time t0. While 1 over E is a very convenient number from a mathematical point of view, it is easier to think of the time t1 half it takes for half of the muons to decay. So this time, t1 half is called the half-life of the particle. Kung kanina, kinuha natin yung kanyang lifetime, ngayon naman, hahanapin natin yung kanyang half-life, kalahati ng lifetime. So in figure 26, we can see that the half-life T1 over T is slightly shorter than the lifetime T0. So remember, T0 represents the lifetime. To calculate half-life from T0, we have, lalagyan lang natin ng 1 half, and it will give us 1 half, no? Again, taking the natural logarithm of both sides of the equation, 1 half t equals negative t over 1 half over t. It will give us 0.693 negative. Okay? So remember, hindi tayo nag-divide ng 1 half, no? Multiply natin siya, kinuha natin siya as a natural logarithm. At if you use the ln, multiply by the half-life, we will get the half-life of the muons, no? Or the half-life formula, which is the 6.93 TO. From the equation 165, you can see that half-life T1 half is about 0.7, you round up, of the lifetime T0. If the muon lifetime is 2.2, we will abbreviate microsecond as USEC. Yung Greek kasi na symbol na to represents micro. So microsecond. When you start with a large number of muons, you would expect about half to decay in a time of, ito yung ating factor ng half-life, 0.693 times the 2.2 microsecond ni muon. So it will give us 1.5 microsecond half-life, no, ng muon. The basic feature of the exponential decay curve e to the minus t over TO is that for every time TO that passes, the curve decreases by another factor of 1 over E. The same applies to the half-life T over, or T 1 half, or the half-life. After 1 half-life, then again, it is divided by another half-life. Katulad na nakita natin sa kabila. No? So, after 1 half-life has decreased to half its value, After second half-life, the curve is down to 1/4. After 3 half-lives, it is down to 1/8. Nahati siya ng nahati by half. Lifetime, half. Yung half nito, inati uli half. And then yung half na to, nahati uli. And it will give us the 1/8, no, of the portion. That illustrate the nature of exponential decay. Suppose that you started with 1,000,000 muons. How long would you expect to wait before there was, on the average, only one left? Gano'n katagal bago siya maging isa na lang, no? Isang muon. To solve this problem, you would want the number e to the negative t over t0 to be done by a factor of 1,000,000. So, kasi sabi natin, only one left. So, 1 times 10 to the 6 negative 6 power gives you 1,000,000. Taking the natural logarithm will give us negative 13.8. To calculate, enter 1 using the calculator, no? Then press exp key and enter 6. Then press positive negative to change the sign of the number. Then finally press equals to get the answer, negative 13.8. Just follow the formula and then press ln. It will give us 13.8 times the standard lifetime of 2.2 of all muons, and it will give us 30 microseconds. That is the nature of an exponential decay. While you have nearly 500,000 left after around 2 microseconds, they essentially all gone by 30 microseconds. Or within 30 microseconds daw, isa na lang ang matitira sa dun sa particle. Okay? So that's it for our calculus-based physics part 1 lesson for our finals.